Today we're going to go over the 2.1 to 2.4 study guide. Please remember the test will be tomorrow. If you are a remote learner and you're taking your quiz at home, please remember that you are expected to take your quiz during your scheduled geometry period. If you do not take it during your scheduled geometry period, you will be deducted points, a lot of points. So this is now, we've had a few quizzes and tests, so everyone should know when they're taking their test. If you have, or their quiz. If you have any questions, please email me. All right, so number 1, what is the next letter in the sequence? A, B, D, G, and K. So what we want to look at is we want to see, okay, well, how many letters am I going from A to B? Well, that was just one letter. How about B to D? Well, B, C, D. Okay, so that was 2 letters. D to G. D, E, F, G. That's 3 letters. And then G to K. G, H, I, J, K. That was 4 letters, which means we're going to be having to add 5 letters to K. So K, L, M, N, O, P. So P is going to be our answer. Draw the next shape that comes next. All right, so if we look at our figure, the first figure we notice that we have 1 box and triangles around it. The next figure we have 2 boxes and then triangles around it. The third figure we have 3 boxes with triangles around it, which means our next figure we're going to have 4 boxes and triangles for each box. Perfect. All right, next, show the conjecture is false by finding a counterexample. Remember, you only need to find one counterexample to prove a conjecture is false. So for number 3, the product of 2 prime numbers is even. All right, so 2 prime numbers is even. The product means multiply. So I need to figure out 2 numbers that are prime that when I multiply them together, their answer is odd. So one example that you could use would be 7 times 7. 7 and 7 are both prime numbers. When you multiply those together, you get 49. 49 is an odd number, not even, so this is a counterexample. I just disproved that conjecture. 4, the quotient of 2 whole numbers is a whole number. A quotient means division, so I just need 2 whole numbers, which are just pretty numbers, and they're telling me that the answer would then be a pretty number, a whole number. So I want to do a quotient, a division problem where my answer would be either a decimal or a fraction. So 2 whole numbers, I don't know, let's say 5 and 2. Those are 2 whole numbers. Let's divide those. If I divide those, do I get a whole number? And the answer is no, 2.5. That is not a whole number. And so I just disproved this conjecture. All right, next we're going to get into writing the converse, inverse, and contrapositive from looking at our conditional statement. So for number 5, our conditional statement is if x is odd, then 3x is odd. So let's first type out or write out our p, which is the x is odd, and then our q, which is 3x is odd. So the converse is if q, then p. So I'm taking my conditional statement and flipping it around. So I'll write that down. If q, then p. I'm going to apologize ahead of time for my handwriting. So our converse then would be if 3x is odd, then x is odd. The inverse is taking our original conditional statement and negating it. So instead of if P then Q, it would be if not P, then not Q. All right, so in our example here, it'd be if x is not odd, then 3x is not odd. And lastly, the contrapositive. The contrapositive is actually going to take the inverse and flip those statements around. So if not Q, then not P. So with our example then, it'd be if 3x is not odd, then x is not odd. And once again, I apologize for my handwriting. Number 6, if a shape is an octagon, then it has 8 sides. So once again, let's start off with writing our P and Q. So P would be the shape is an octagon. And our Q would be it has 8 sides. All right, so the converse then would be taking our P and Q statement and flipping it around. So if it has, I'm just going to use the letter 8 sides, then the shape is an octagon. The inverse is taking our original statement and negating it. So if the shape is not an octagon, then it does not have 8 sides. So if the shape is not an octagon, I'm just going to put oct, then it does not have 8 sides. And remember, tomorrow you won't have to type anything into Polaris. They're going to be just drop-down boxes or multiple choice, just like your in-class assignment was. So the contrapositive then is taking the inverse and flipping those sentences around. So if it does not have 8 sides, then the shape is not an octagon. So if it does not have 8 sides, then the shape is not an octagon. All right, let's move this back up. Next, we have a biconditional statement. So write the following into a biconditional statement. Remember, biconditional statements are statements that say if and only if. So if an angle is a 100-degree angle, then it makes a line. So how I would write this is an angle is 180 degrees. If and only if, and remember you can use that if with 2 F's, that means if and only if it makes a line. Make a valid conclusion if possible in the situation. So if x plus 3 is equal to 8, then x is equal to 5. That's our statement. So I'm going to say that again. If x plus 3 is equal to 8, then x is equal to 5. So now our next statement is saying, well, hey, x plus 3 is equal to 8. So what can I conclude then? Well, the only thing we can conclude is that x is equal to 5. And this would be an example of law of detachment. Next, if you are in band, you play an instrument. You play an instrument. Let's go back to our original statement. If you are in band, you play an instrument. If you are in band, then you play an instrument. If we know they are in band, that's the only way we can conclude that they play an instrument. The next statement starts with what the second part of this statement was, if you play an instrument. So what can you conclude? We can't conclude anything. So this is invalid. It does not follow the law of detachment or the law of Sill. So if they told us, or if the second statement started with you are in band, we then would be able to conclude you play an instrument. But because that sentence is saying you play an instrument, we don't know what that means. We cannot conclude anything. So the answer there would be invalid. 10, if Blaine goes to college, then he will take chemistry. If he takes chemistry, he will need safety goggles. Blaine goes to college. So what can we conclude then? Well, this is the law of Sill. If P, then R. If R, then Q. Therefore, if P occurs, R will also occur. So if Blaine goes to college, that's P. He will take chemistry. That is R. If he takes chemistry, that's R. He will need safety goggles. That is Q. So therefore, if Blaine goes to college, he will need safety goggles. So he will need safety goggles. Sorry, the T. And once again, that would be the law of Sill. Number 11, if you go to study parties, then you will get good grades. You go to study parties. All right, so what can we conclude? So let's go back to our original statement. If you go to study parties, then you will get good grades. The next sentence starts with you will go to study parties, so we can then conclude you will get good grades. You will get good grades. Number 11, when two lines intersect, their intersection is a, now you got to go back to remember all of your postulates that we learned in 2.4. So if you scroll down, or if I scroll down and you look at your study guide, here are all the postulates. You need to know these. You don't need to know them word for word, but you should be able to recognize them in a question, just like this one in number 11. So when two lines intersect, what is their intersection? It would be a point A. And that's it. So remember, this is an open note quiz, so you can use this study guide on your quiz. I would also make sure your notes are all organized. You do only have 50 minutes to complete this quiz. That should be plenty of time, as long as you know what you're doing and you're organized and you study. Good luck.